Hi, this is Lars from Astral Dawn Studios. Today we'll be taking a look at the single responsibilities principle, a design by which developers can write more granular classes offering for greater flexibility and maintainable code bases. It was first introduced by Robert C. Martin as part of the SOLID mnemonic acronym. We're going to start off with some theory in the video, going over what the single responsibility principle means and a theoretical example of how we can apply it, and then later on look to actually develop it within a sample Unity game. If you wish to see the development, make sure to click the timestamp in the description below. So what exactly is the single responsibilities principle? Each software module, or a finite construct of logic within your software, should have one and only one reason to change. That meaning, a class, for instance, which captures a particular responsibility, should only have to be updated when that specific responsibility is updated or altered, and shouldn't be handling two separate ones for which there would be two different reasons for it to change. So let's take SRP to a theoretical example. Let's imagine we're running a burger joint where all the staff that we hire are in fact robots, and these robots have no machine learning or AI algorithms within them, and instead only follow a set series of instructions that we give them. These set instructions can then be acted upon when we trigger a specific button, or there's a particular entry point on the robot where we can say, okay, start doing this particular series of instructions. So a robot can have more than one set of instructions. That's important to note. So let's start thinking about what one robot within our burger joint will be responsible for if they are to be delivering the whole service of our burger. So we'll call this one burger joint robot. It's a bit vague at the moment, but currently its responsibility lies upon taking care of all the action that's necessary within our burger's business objective. That being to take an order, produce that food or produce the order, and then serve that to a customer. So let's write these out as a set of instructions that our robot can follow. The first instruction might be to take an order from the customer. Our second instruction might be to receive payment of some kind. Our third one might be to produce a receipt. And just to mark the take order somewhat differently, I'm going to give it a green, indicating that this is where we can actually trigger this particular set of instructions, just so it's a bit more clear. So imagine it as a big green button on the back of the robot, which we can click to initiate this process. So the next one after the produced receipt will probably be to enter the kitchen, for example. Then it might be to produce the burger itself. Then we will, let's say, we'll return to counter, or let's say return to dining area. It's fine. And then we're going to say serve burger. So these grossly simplified instructions for our robot work, and when a customer comes in, they might make an order, and that triggers this green button here, or this initial step to take the order. So they pass the speech, perhaps, that the customer is talking, and then from that it can then derive the particular steps it needs to follow to produce the food, and then finally serve it to the customer as an end goal. So it works, and our customers are delighted with their tasty burgers. But when looking at these instructions, we can see that we're not following the single responsibilities principle. If we're imagining that our robot is in effect a class in an object-oriented programming language, we can see that it has many more than one responsibility, at least within the system of a burger joint. So let's try and break these responsibilities down. So there, to me, are three distinct steps here, also three distinct responsibilities which have a set of separate actions, I suppose, as part of the instructions. This responsibility would probably come under the customer order. So there's this responsibility of handling when a customer is ordering, includes these three specific tasks of taking an order and receiving the payment and producing a receipt. Next, I would probably outline these two. The enter kitchen and produce the burger probably comes under a separate responsibility of food preparation. And finally, these last two is the handling of food serving, let's say. With our one entry point here on the robot for taking an order and then carrying out the three separate responsibilities within the same set of instructions, we can see that we're not conforming to this this singles responsibilities principle. But if it works at the moment, we as developers are content for the time being. Let's perhaps move forward and see where this particular approach might get a bit more messy. So the burger industry is a competitive one, and our stakeholders are getting a bit anxious, and they actually want us to make a change to our system to allow customers to actually order their burgers online. So now the step in which the robot will take an order face to face, let's say, or personally, that will need to be updated. There's also the additional responsibility that food serving will also need to be updated, as the customer will no longer be in the facility and actually on a remote location, which will require delivery for the robot to carry out. Let's write a second method which handles this particular job, ordering online. So we'll just copy these ones across. And this is still going to be part of the same robot. He's working there as a one-bot army. And here we'll have we'll have to update this take order to take order online. Receive payment will be the same, except it will be via some, let's say it's electronic payment. And just to distinguish these a bit more, we'll say this one's receive physical payment. And then this produce receipt might instead be to email the receipt to the customer who's ordering the food. However, the robot is still going to be entering the kitchen and producing a burger. So in fact, the responsibility of food preparation has not been changed. But in essence, it has been altered in that because the customer order, though being a completely separate responsibility, has had to change, it's actually having a direct effect on this sequence of instructions, including the food preparation. So the robot enters the kitchen, produces the burger, and now instead of returning to the dining area, it might want to enter the garage. Let's say the bot can drive a car. These are quite sophisticated machines, and then deliver food. So again, we've had to update this food serving responsibility as well to handle an online service at our burger joint. So if we go back to what Robert Martin had said, in that the single responsibilities principle ensures that each software module has one and only one reason to change, we can see here this example that we've actually had to make a change for two separate reasons on the same bot. And where this might get sticky is in that our robot just handles far too many responsibilities. So here where we actually have the food preparation responsibility, we've actually had to replicate it in these two separate entry points for our bot. So for instance, when the user or when someone presses the take order online button or initiates that particular process, they're still going to enter the kitchen and produce burger, and likewise with the take personal order. And this can get very messy pretty quickly because, for instance, if we wanted to make a change to the produce burger step, say for instance now with each burger that you ordered from our joint you also got an additional portion of fries, it would mean that we'd have to update the food preparation responsibility in two different locations. That being, we'd have to update it as part of the take order online entry point or the method, and also the take personal order method as well. And our instructions are also not particularly flexible. Let's say for instance the next day that our stakeholders come to us and say, well, we've thought of this new crazy idea in which the customers at your venue can actually order online from their table and then the food still be delivered to them within the venue itself. Then we fall into the issue of having to update the food serving aspect for the take order online. So because we lack the flexibility, we might have to add an additional green button here on the burger joint robot to handle the responsibility of taking an electronic payment, perhaps emailing the receipt, and then instead of entering the garage and delivering the food via a motor vehicle of some kind, it would perhaps just return to the dining area and serve the burger. And again, this would be replicating a lot of our code, and that avoids the dry pattern of do not repeat yourself in code, to avoid having to make many changes in your code base for one particular change. So let's see how we can apply single responsibilities principle to this particular example. So if we're going to look to find those responsibilities which are small enough for our software modules to manage, in this particular scenario, a software module would be a class that could reflect perhaps our robot. So this robot here is our class, and as part of its behaviors, it has these two methods which can be invoked: the take order online and the take personal order. So if we can try and break down the burger joint's robot responsibilities, we can then delegate them to separate classes. So a good method by which you can accomplish this is the divide and conquer algorithm, where you take a problem. In our scenario, it's running a burger joint, and you recursively break down the problem into subproblems until these subproblems are simple enough to capture in code or within a responsibility in this case. So let's take a look at our example. So I'm going to leave this diagram here. We have the burger joint robot, and let's talk about breaking down this the responsibility. And we already have these examples of responsibilities here, but because we're recursively breaking them down, it's best to try and split them into two where possible. So let's assume that we have one responsibility which is customer service, and we have another which is food preparation. And then from these we can break them down even further. So for instance, customer service, we know is going to include a step to serve food, and then it's also going to include a step for taking orders. And food preparation is actually, it's a fine enough responsibility, especially if we look at our predefined instructions where we have the enter kitchen and produce burger. That seems good enough to be within its own responsibility. So we can break these down even further. So for instance, serving food, there are two separate ways in which this can be accomplished. So the two separate ways being remote delivery and also venue serving. And in regards to taking orders, again we have two different ways in which this can be accomplished. There's online orders, and then there's also in-person orders. Okay, so we've broken these down. A trap that you can sometimes fall into with single responsibilities principle is sort of giving a class sort of a one method solution where each of your classes handles one specific thing and has only one entry point. And the issue with that is it sort of defeats the point of object-oriented programming to begin with, because at that point you might as well use a procedural language where the classes don't exist, or instead a functional one. So it's good to sometimes take a step back and look at it a bit more at a high level and think about, okay, so remote delivery and venue serving, sure, they could be looked at as two separate responsibilities, but in my opinion, or in my eyes, I see these two being two different methods by which you can accomplish the same responsibility. So we can group we can group them like that in that particular way. The same goes for taking orders. In principle, it's the same responsibility that's needs to be fulfilled, but there are two different methods by which we can go about it. Now let's take this to writing up our instructions. So in our example here, where we have the burger joint robot, now we can look to actually have three separate robots handling three separate responsibilities. So we have our serving food robot, taking orders robot, and finally we have our food preparation robot. And like the robot that we had in our previous example who was running the whole burger joint, these robots can have multiple buttons on them. We'll call them buttons for now. They're basically invocations of a process. Let's start with the taking orders. Perhaps let me just realign these to make it a bit neater. So in taking orders robot, there is we can actually drag and drop the particular step. So we can agree that the responsibilities that we're going to take on or delegate to specific specialized classes are going to be the serve food, the taking orders, and the food preparation. So we can mark these as red. So for that reason, I've defined these robots down here. There's the taking orders robot, which of course handles this responsibility. The food preparation robot, of course, reflects the particular responsibility that's going to take on, and the serving food robot. And like the burger joint robot, they too can have multiple buttons, or referring to them as buttons, but let's call them entry points, by which you can actually call for action on a particular set of instructions. So we actually have all the individual tasks that make up these particular steps defined here, so we can actually drag and drop these to where we feel they would work best. So for instance, taking order online and taking personal order would be two separate methods defined as part of the taking orders robot. Let's put these here. Might get a little bit squashed, but let's see. And then the food preparation robot is probably just going to have a burger. It's probably just going to have a method entry point, say enter kitchen, or I think at this point, because the here we had to assume that our robot was actually moving from the counter after taking an order into going into the kitchen. But now the robot is specialized in food preparation, we can just say, okay, it's just responsible for producing the burger. And this here would also be a button on the robot that we can trigger. And then also the serving food robot. So this one can perhaps enter the garage or instead return to enter the dining area. Okay, so now we can start to flesh out these particular instruction invocations. So for instance, taking order online, we can just take a look at what steps we have here. So receive electronic payment and email receipt, we can copy these across. There's also the taking personal order, so again, receive physical payment and produce receipt. And then for the food preparation robot, it's actually just simply producing the burger. There might be an additional step here, let's just add it for now. It's ready burger for serving. There we go. So that would just be, for instance, it would put it in some sort of a burger queue or order queue in which the serving food robot could then go pick it up for them. As part of the serving food robot, we have the enter the garage and deliver the food via, I don't know, some form of transport, and here simply serve burger directly to the customer. So now you can see that our sets of instructions are far simpler, and that we have far more entry points or buttons that we imagine on the robots for us to trigger, and we can more dynamically use these together so to pick and choose which particular sets of instructions we want as part of the responsibility to sort of combine and make a more flexible ordering process or burger production pipeline. So you could ask the question though, so the taking orders robot, once it's finished its particular task, how does the food preparation robot know to actually start producing a burger? And the same goes for, okay, so we ready the burger for serving, but the serving food robot still needs to be invoked. And to achieve this, you could actually create a completely new responsibility, and that would be managing the burger joint. Similar to how you would probably in a fast food restaurant have a manager, we can define that underneath here. And then what this would do is, it would understand the context of the order throughout the whole pipeline, or our process pipeline, and know which particular actions to invoke on the particular robots. So in fact, it would go about and probably, if we're imagining it in our theoretical world, it would go about and actually press the buttons on the back of these robots to initiate the specific tasks. And because it's aware of the context of the order, it knows whether, for instance, it was an online one, or it was a delivery that needs to be made to a remote location, or instead one directly at the venue. It can then, knowing that information, make the specific calls in our burger production pipeline. So now we can welcome change from our stakeholders, because we have this sort of more flexible system by which we can pick and choose the specific actions for for separate responsibilities. For instance, say the food preparation now took on a different task of producing ice cream or fries or something along those lines. We can just simply add another button or another entry point to our robot to handle that specific task. And again, it's very important with single responsibility principle not to get carried away and take it too far. Again, if you feel like you are doing that and your code is actually becoming less maintainable and more difficult to manage, then it's good to take a step back and sort of look at it from perhaps a higher level. And that can often be a better method by which to group up the different ways in which a responsibility can be tackled. So let's shoot off some of the advantages that come with using SRP. So the first is flexibility in separating the responsibilities of your classes. As we saw with the example previously highlighted with the burger joint, we can more flexibly pick and choose the different methods by which you can approach a particular responsibility as part of the whole system that you're dealing with. And to add with that, it's always better to have a more flexible code base, especially within something like video game development, where designers are frequently requesting changes or updates to either an existing feature or a new one that they want. And as developers, it's our responsibility to ensure that the code base is less afflicted by change. So reusability, dry comes to mind, the idea of do not repeat yourself within your code base. If you, for instance, have a particular method by which to accomplish something, it's better to write it once and invoke it from from different areas in your code base, as opposed to copying the logic that's included within that method into the various different locations of your code base. As if a change is required to that method, then you'll have to make it in many different locations as opposed to only in one place within your code base. Separation of concerns is a great advantage with using single responsibilities principle, as it means that making a change to one class which handles one responsibility should have no direct effect on another class which handles a completely different responsibility, meaning you can be confident in code changes that you make to one particular class having no implications on other classes within your system. Logging and debugging also becomes a lot more straightforward with single responsibilities principle, whether it is you want to attach a specific logger to each of the classes that you define, making the log output easier to use when navigating through your code base and debugging a particular problem. And also debugging itself becomes more straightforward because when you look through the stack trace, you can see the different methods which are being invoked on the separate classes and more quickly find those lines of code which are actually causing the issue. Encapsulation, also a benefit with single responsibilities principle. It basically ensures that your classes know just enough to carry out their responsibilities and sort of avoids that anti-pattern of the God object, where if we look at our burger joint example, the burger joint robot was handling everything and it knew too much, thus that we fell into the anti-pattern of the God object. Here, with a single responsibilities principle, we know that our classes will be encapsulated with private state data for example, for the different tasks they need to carry out, and that they know just enough to carry out their responsibility and not more. Nomenclature is also made easier with single responsibilities principle, something that I find particularly difficult, I suppose, in programming and development in general, is the naming system you use and making sure that it's easily understandable for someone new to the code base to understand, I guess, what it is your classes are doing. With single responsibilities principle, you can simply say, okay, what's the responsibility of this class, and then give it a name that suits the sort of enforcement of that particular responsibility or application of it. So better organized file structure. This one's perhaps a bit more subjective. I know personally I find it a lot easier to come to an alien code base and it be split into the separate files because a class would most likely be within its own file. So for me, I find it easier to navigate through the code base and find where I can see the actual tackling of a particular responsibility within the system. However, I have worked with developers in the past who have found it a bit of a pain to have to nestle through the responsibility chain to actually find the lines of code that they're looking for or to try and understand it. It definitely can create initially a bit more of a steeper learning curve when looking at a new code base. So teamwork is also made a bit more straightforward. If you're using a version control system such as Git, you probably have found in the past that it can get a bit messy when you're working with more than two people or so, because if you're working on the same files, you'll often come to a point where you'll need to make a merge, and when that happens, it can sometimes get a bit messy and a bit difficult to understand what code needs to stay and what code needs to be removed. With SRP, because you're separating the responsibilities out into separate classes and thus separate files, it's much more easier in a team to work on different elements of your code base, different parts of your code base which are not interlinked at all. And then when it comes to making a pull request, the merges are a lot smoother generally. So unit testing is greatly simplified with SRP, and of course it makes sense. If you imagine that you have one particular method which handles the entirety of your program, the test cases for that are going to be numerous and of course quite complex depending on the complexity of the program, of course. But if you break down the logic within that program and delegate the responsibilities to separate classes with different methods as entry points, then you can test those individual entry points, and their unit tests will probably be more simple, while you may have more of them. So some of the disadvantages that can come with SRP is that you can have quite a stretched out code base where your files perhaps don't have particularly much content, and it means that new developers, at least coming to your project, they might have a steeper initial learning curve for understanding perhaps the different ways in which your classes are accomplishing tasks as they're in a more broken down format than perhaps something like a procedural script where they can simply read it through like a recipe. So another disadvantage can be that taking SRP too far, so single responsibilities principle, to an extreme level, you can end in this position where you have these classes which literally have only one method, making it somewhat redundant doing object-oriented programming where the objective is to sort of group behaviors for these classes. And at that point you might as well look to do something perhaps functional or procedural instead. A good way to sort of avoid doing this is if you find that you're making a lot of classes which have these one methods and that's all they're doing, then a good way to get about doing this or to at least resolve it is to take a step back and think perhaps you're looking at it at too low a level, and try and look at it from a higher level and understand, okay, maybe we can group some of these different, what you might assume to be separate responsibilities, but let's try and group them under one responsibility and say, okay, these sub-problems under this responsibility are actually different methods by which I can accomplish the responsibility that now is delegated to a class with the separate methods. And again, it's also just a case of if you find that you're enforcing SRP and you've actually making your code more complicated, or perhaps it's less maintainable, then you know you're going off tracks with SRP, as it's simply meant as a method by which to make your code more maintainable and easier to understand. So it's at that point it's definitely a good idea to reflect and think about perhaps reeling it back and grouping up some of these originally thought separate responsibilities into a perhaps more compact class. So we've looked at the theory and what the single responsibility principle is. We've also looked at some of the advantages and disadvantages. Let's take to using this at an actual use case of video game development using a sample Unity game. So before we actually get to the development, let's look at the specific use case that's been put forward. So our design team has come to us and they've asked us to develop an environment in which the following objective can be completed. So we need a character who can move left and right within a 2D space using the arrow keys. It can also jump when grounded and the user presses the jump button. So right off the bat, it seems something somewhat straightforward, and I'm sure it could be easily accomplished within Unity. The objective here is to sort of highlight how we can use single responsibilities principle to perhaps make our code base more flexible for any future changes that our designers might come to us with. So let's get to breaking down this design that's been put forward. So we know that we're going to need some sort of a player that the user is going to actually control, and then let's have a look at the separate responsibilities, or at least try and break this down. So there are two main responsibilities highlighted here, and this is the ability to move horizontally using the arrow keys, and of course also one to be able to jump. Perhaps something I hadn't highlighted as obviously was that it's a platformer. So that is why instead of if you're moving within a 2D space using the arrow keys, it probably could be more obvious that it needs to be moving left or right as opposed to moving in a vertical direction. So here if we highlight, there's a responsibility to be able to jump and a responsibility to move horizontally, let's say. And from here, let's try and break these down even further if we can. So we know that moving horizontally depends on the user inputting with their arrow keys. So we know that there's going to be a responsibility for, say, determine direction. And then there's also the actual application of the direction, so the actual enforcing of moving left and right. So this is what we can actually call apply movement or something along those lines. So with the jump, what might we have? If we put this over here, well, there's going to be the actual apply jump. So if you imagine, if we're talking about in Unity, if you're thinking about enforcing some sort of physics, it would perhaps be on the rigid body. So the apply jump and the apply movement would be altering the velocity perhaps of the rigid body so that it can move in the particular feature, or in accordance with the feature. So there's another responsibility for jump, and that is whether or not the player should jump. As highlighted in the design that's been given to us, the player can also jump when grounded and when the user presses the jump button. So these are two different responsibilities that we could break even further into. So if we crack these down, and here we say, okay, so user presses the jump button. Let's say determine user input, and let's put another one, put these a bit more to the side just to indicate that they're part of this responsibility, or at least they were broken down from this problem. And the other one is grounded. And then from here we can sort of work up this tree to say, okay, determine user input is grounded, and then that responsibility is fulfilled. And breaking it down in this sort of a way means that our code, if we go about developing it this way, will be more flexible in the future. Say our designers come to us and request that, okay, we want an enemy or an AI that jumps, and perhaps in accordance with a timer or so, we'll be able to reuse the code that we've written here, for instance, for the apply jump and the is grounded, because the enemy probably as well will choose to only jump when grounded. So we can use both of these particular methods that we might write and reuse them as part of the enemy, but perhaps instead of determining user input, we would have a completely separate responsibility, which would be perhaps enemy timer or something along those lines. And that just means that we're less heavily afflicted by change, and we can smartly approach any new requests for features that our design team comes to us with. So with that out the way and our design written out in the sort of flow diagram, or this breakdown diagram, let's actually get to developing the game in Unity. Okay, so I've created this sample Unity project, which is really straightforward. We simply have a grid with a tile map, which we've created directly from the 2D object. Onto it we've actually applied a composite collider, so it will apply collisions to any other rigid bodies that come in contact with it. We've also rendered this simple brown tile via a tile palette. Additionally, we've also added this player who has a rigid body as well, a 2D rigid body, box collider, and also a sprite render where we've added this simple red square sprite. So if we run this, what we should expect to see is that the red box should fall and collide with this static composite collider. So if we just press play, and you can see that our body sits there and we can't move it or jump. Okay, so let's start with the development of the instructions that have been given forward by our design team. So if we look at the scripts directory, we're going to create an assembly definition, and we'll just mark this as source. And we'll also create a new script. And we'll call this player for now. I'll probably move this about a bit because I quite like to have an organized file structure as part of my project. But at least for gearing Visual Studio up, I find it best to create initially a script in Unity, Unity's editor anyway. Great, so we can see that we're in the assets scripts and we have this player script. So actually within here I'm going to choose to add a new folder, and we're going to call this bodies or something. And we'll just move the player in there. And with better organization, it's always good to have a namespace. So here I'm going to use assets scripts and bodies, and we're going to move this in. Oop. There we go. So we have this public player class, which is deriving from the mono behavior, the Unity sort of default script parent class. So as part of this player, at the moment we can just leave it quite simply. We might, for the time being anyway, we don't have any way in which to invoke these responsibilities because they don't exist yet. So let's take a look at the horizontal movement as our first example. So we might want to create it within the scripts, a new folder, and we can call it behaviors. And we're going to say new item, class, and we'll call this one horizontal movement. And it's handling the responsibilities of applying a direction onto the player, or the rigid body that's going to be presented to it. Okay, so we're going to have a public void method, and we'll call it trigger, and this will take the argument of the rigid body that's going to be passed down to it, in which the speed should be applied. So we're going to say, okay, rigid body 2D, I'll just alt enter. get the Unity engine, and we'll just call that RB, and we'll say, okay, var horizontal velocity equals, for the time being, we're just going to say 1f. I'm going to say rb.velocity equals new vector 2. Ooh. And we're going to have here the horizontal velocity, and we don't want to make any change to the current velocity in the y-axis, as gravity might be being applied, and we want that to continue happening and it to be consistent, at least, or not altered, at least in reflection of whether the body's moving horizontally. Okay, so this method will simply move the red cube, or the red body, the player, horizontally rightward at a speed or a velocity of 1. So as part of our player, let's actually invoke or call upon this horizontal movement responsibility. So what you might want to do is, just as part of the void private void start, we can actually, if we say we have our own property for the horizontal movement, so let's call it, it's going to be of type private horizontal movement, and we'll just hold enter, and scripts behavior. And as part of the start, we're just going to say, okay, this is going to equal a new instance of our horizontal movement class. So we're going to populate this property, or at least this property reference is going to point to this new instance of the horizontal movement class, so this object. And then as part of our update, we're just going to say, okay, horizontal movement, and we're going to call trigger, not toString, trigger. Of course, it's expecting a rigid body here. So we've got to then again collect the rigid body that would exist on this player. So as part of our start, actually first off, we'll create a property for it. So if we do private rigid body 2D, we say like so, and we can do rb equals get component rigid body 2D, and that way we populate this property, and then this property on start exists, and we can actually pass that into the horizontal movement, which then enforces the actual movement on the body. So if we go to our player and we add that script, there we go, player, nice. If we press play now, we should expect the red body to just simply move rightward off the cliff. So let's give that a go. And sure enough, it slowly but surely falls off like a green Koopa Trooper. So there are some issues here. Again, with our horizontal movement, let's say, for instance, we want to change the speed. We want it to be a bit more dynamic. So, for instance, here we're stating as always 1. The velocity does not reflect a particular direction that we pass it either. So we'll need to amend this change for that. So to begin with, we'll just start with allowing a developer to more flexibly alter the speed at which the body moves. So to do this, we're actually going to mark our horizontal movement class as serializable, and we're going to mark a serialized field here as well. It's going to be private, and it's going to be of type float speed. And Unity sometimes complains if your classes have private properties that don't have default values, so we're going to assign it here. Let's just say the default value would be 5f, or sorry, a value of 5 as a float. And now we can say, okay, the horizontal velocity is in fact going to be equal to the speed that we give it. Additionally though, we also want to make sure that we pass in a direction. So we assume our direction is going to be represented as a float, probably of either a negative or a positive 1. We can just mark here float direction, and then we can multiply our speed by the direction. So for instance, if the direction wanted to have been in the leftward, we can simply pass in -1, multiplies the speed by -1, and our body will move at a velocity of -5. Whereas of course vice versa if you wanted to move rightward. Okay, so that's not all yet, though. We need to change, as within the editor, or the Unity editor, we don't have visibility of this horizontal movement. In fact, this is something that is instantiated as part of the player. So instead what we're going to do actually is we're going to create a serialized field here for our horizontal movement, as it is a serializable object. So we say serialized field horizontal movement. We no longer need to say, okay, horizontal movement, we're going to establish a new instance there. Instead, we're just going to fill in the details as part of the editor, and it will actually be injected on runtime. So horizontal movement.trigger RB. Okay, and we also need to pass the direction, pass the literal 1, so it's going to move rightward. Actually, for the sake of the example, let's pass in -1, just to ensure it works for sure. Okay, and now if we go to our player script, as part of this player script, we've actually got this horizontal movement section, as it's a serializable object, and we can actually specify the particular speed we want to use. So if we say, okay, we want a speed of 3, we should now move leftward at a speed of 3. So let's have a look and make sure that works. Nice. So in terms of the actual application of the horizontal movement, I think we're fairly content with this, or at least good enough to move forward. The next responsibility in the horizontal movement is perhaps which input I'm pressing and how I can control that. You might think, okay, let's create an input controller of some kind, but in fact Unity already has a static class to handle this. So what we can do is, as part of this -1f, we can simply say, to make it a bit more clear, we'll say var horizontal direction equals input, and that's the static Unity class, and get axis raw, as we don't want it to have any in-between values. It will just simply be -1 or 1 or 0 in the event that there's no user input, so that your speed is multiplied by 0 and there's no, the velocity in the x-axis for our rigid body will be 0. So here we need the particular axis name, and I suppose this is a bit more of a general Unity piece of information, but I just want to point this out because there's a particular thing that I do that I find quite helpful, is that as part of our project settings, there's the input manager, and we have these axes listed, and here we know that, for instance, with the horizontal movement, it's as part of this axis labeled horizontal, and the jump, of course, again, is an axis labeled jump. So if we wanted to reference these would be the string literals we would populate the input get button down or input get axis raw with. So something I find quite useful is actually centralizing the location for these particular mappings. That means if I make a change, or any developer in the team makes a change to the input manager axes names, it can be changed in only one location, or it needs to be changed in only one location. Say for instance, we created another script, say perhaps this wasn't so specific and wasn't player, but perhaps it was like a hero or a knight or something like along those lines, and then we created another one and we labeled it dragon. While the dragon would have different functionality, it could perhaps fly or something along those lines, it would still perhaps require user input, and thus we would potentially end up using the same string literal in 2 different locations, meaning if we were to make a change there, we would have to go and change it in different locations. So as part of our scripts directory, let's add a new directory, and we'll call it common, as it's going to be data that's common across our project. And we'll create a new file, and we'll call this one game constants. And this is actually going to be a public static class. And within this, we're actually going to we're going to nest a public static class again, and this will be input mappings, and this is going to be a public const string horizontal axis, and this is going to be horizontal, and then we'll define another one, public const string. Okay, so if we go back to our player class and we look at where we were looking to do input get axis raw, we might have been tempted to write in here horizontal directly as a string literal. Instead, now we can just reference our constants. So if we do input mappings dot, well, first we'll do alt enter on it, and you can see that we're going to be using a static reference to the asset scripts common namespace or game constant static class, and we'll do input mappings dot horizontal axis. So now that we're populating this horizontal direction, we can pass it into here. And this means that it's either going to be -1, 0, or 1, and we're passing it into our horizontal movement script to determine which direction, or if we're moving at all. So let's give this a test and make sure it works. And you can see that we can move left and right using the arrow keys. Can't see my fingers, but you'll just have to take my word for it. If we topple over the side, there we go. And I don't know if you saw, but at the bottom there was a message about a serialized property which isn't populated. So here on the horizontal movement, to just avoid those pesky warnings coming up, we'll just put a default here, and that should get rid of it. Okay. So this handles the horizontal movement aspect of what our design team has asked us to complete. So let's look at the second example, which is the jumping. So if we go back to our diagram, these tasks have been completed. We'll just mark these as red for some reason and say that they're done. Probably green would have been a nicer color, but who knows. So now we'll look at completing the jump. So like the horizontal movement, let's perhaps start with its with one of the simpler responsibilities, and that is simply just applying the jump itself. So here in the behaviors, we can choose to create a new script, and we'll call this jump. And again, this will be a public class, and it's going to have a public void trigger method, and within that we're going to pass our rigid body 2D again. So we're going to say, fair enough, RB velocity is equals a new vector again, and as an opposite to the horizontal movement, we don't want to affect the movement of the object in the x-axis. Instead, we only want to affect the y velocity of our of our rigid body. So here we're going to apply some sort of a number. So let's for now say 1f, 5. Oh, yep. There we go. And in our player, again, we're going to probably want to serialize our jump. So if we go back to our jump, and like the horizontal movement, we're going to serialize the boo. If I spelled that incorrectly, I have. No spelling bee champion over here. Serialize field, and we're going to have a private float here for actually the height at which, or the force that's applied when jumping in the upward trajectory. So here we're going to have force, and we'll give that a default value of 5. And here we'll just populate that force as well. Great. So now as part of our player, again, we'll probably want another serialized field. And this will be private jump, and we can just call this jump and default. So a jump property of type jump class, and in our update for the time being, we're just going to say, okay, jump trigger, and we're just going to pass in our rigid body and invoke that on every update call, so every frame call. Of course, there are ways that you could manage this to handle it in the fixed update, but for now we're just going to keep it in the update. So let's run this, and we should expect our red cube to sort of stem off to whatever direction I'm passing it in, but it should move upwards now as we're consistently jumping. Yep, and there he goes, shoots off like a rocket. So on our player, let's take a look. Yep, our jump force is the default value of 5, so we could alter this to change the speed at which our boy ascends. And yep, here he's ascending rather slowly, but we can still move. Very nice. Okay, so it's not looking too bad. So we've handled the jumping. It's now just a question of when we should actually apply this this jump force onto the rigid body. And again, if we go back to our diagram, that was broken down into 2 responsibilities: the determine user input, and also the condition as to whether or not the rigid body is grounded. So let's first tackle the user input, which should be somewhat similar to what we were doing with the horizontal direction. So actually I jumped ahead a bit with I jumped the gun a bit when I was defining these input mappings and put in the jump button already here. So now we can say, okay, well, we're going to apply the jump, but only if input.getButton down if the jump is being pressed. So if we do input mappings jump button. Now if we return ourselves to Unity and we press play, we should only be able to jump when I hit the spacebar, as that's what's being mapped. Of course, because I've given it a speed of 1, and that's probably really loud for you guys, but I can't jump very high, so let's just quickly amend that. Okay, let's go back and change that to 5 or something like that. So now our jumps have a bit more weight to them, and we can move about. Of course, because we haven't enforced that condition of you can only jump when grounded, you can simply continuously ascend with infinite jumps. Okay, so that question of the rigid body or the player only being able to jump when grounded is the next responsibility we should tackle. So I would create a new folder and we can call this conditions. And in here we'll create a new class and let's call this, let's think a little bit about how we're going to actually check it's grounded. Let's assume that our approach to this will be just having a small rectangle or an area check that ensures that our player is in fact standing above ground. So a way we might choose to do this, for instance, would be if we mark the ground or the tile map here in a separate layer and then detect a particular layer mask using the physics static functions that are available as part of Unity. That would be an effective way in which we could ensure that the rigid body has to be grounded before we can actually apply the jump. So we'll mark this ground as this ground layer that I've created. Again, you can always just go and add this layer. This was one I actually initially added as part of the preset. So if we mark this as ground, we know that when the player interacts with it and has an area check underneath, it should confirm that it is in fact grounded. So considering our method of checking whether the rigid body is grounded based on an area, determining that it overlaps with a particular layer instance, we can call this box area. Again, make this public and serialize. Make it serializable, as there will be a few serialized fields that we'll need for it. So we can have a public method here that will say check, and in fact, instead of being void, because we know that this will be a check that's used to determine whether or not the jump should be applied, we can ensure that we're going to actually have to return a boolean. Okay, so we can have a method that returns of type bool, and we'll call it check. And for now, we'll just leave it like so, and we'll write how we assume the logic to go about. So we can look at our physics 2D as part of Unity, and see that we have this box, overlap box even, and we can see what types of arguments that actually takes. So this method is overloaded quite a few times. So here we know that we're going to be wanting to look for something where we're going to be using a particular layer. So let's take a look if we can find one. So this looks pretty good. So we have a point from which the box is drawn, or the box is centered, and then we also have a particular size. So that will be as a vector, an x and a y value, determining the size of your rectangle. And then the angle, which isn't so important to us because we assume that it's always going to be flat at the bottom for the time being anyway. And then also a layer mask. Okay, so there's quite a lot of data here that we need to get into our box area class. So one of which is the point. And for this, instead of using the rigid body, which we had used for the application of some of the physics, we can actually instead use the transform, because it's good practice, at least with these actions of responsibility, to pass only the necessary data required. So for instance here, in our check, we might want to pass a transform. Going to pass in the transform position. Next is the size. So this might be something we want to serialize. And we're going to say, okay, private vector 2. So this box size will be our second argument. And the third one was the angle, but we're not too fussed about that, so we're going to mark it as a default. And finally is the layer mask, and again this is going to have to be something which is most likely populated within the editor. Cool. And then we can populate this layer as the fourth argument to our overlap box call. Great. So currently we're not returning anything, so this can be simply updated to return the boolean, or return the collider, which is then converted into a boolean via Unity's .NET features. Okay, so this doesn't look too bad. If we then go back to our player and we serialize this, here we might choose to within our if clause, or within our if condition, we can have box area check, and then the transform, which we can actually populate directly with this. And because it's a condition as to whether both of these are are true, so whether the user has pressed jump and also that the rigid body is in fact grounded, we can use the AND operator. Okay, so let's take a look at how this works in Unity. Okay, so we have our box area and it has a box size, and we can even specify the particular layer which it should react to. However, there are some issues. For instance, for instance, we can't actually see the particular box when we alter these values, and so it's not visible as a gizmo, and so that's a bit of a pain. So let's try and allow our developing life, or make our developing life a bit more easy by actually rendering that within the editor. So if we go over to the box area, we can have a public method, and we can simply say draw, or draw frame. It's perhaps a bit more clear. And again, this takes in a transform, and this will just use gizmos.draw, and we're going to use, I think it's wirecube, that's the one. And this takes a position, and as a vector free, as it can be a three-dimensional cube. But in our case, we actually just want a 2D one, and also the size. So as the position, we know that we can use the transform.position, and as the size, we've already got this box size defined. An important pre-step to this is, so we've defined this method as part of our box area, but in fact we also need to then call this from the player. The reason is we can't have the onDrawGizmos method that comes with Unity's monobehaviors is because this box area is in fact our own class that does not derive from the monobehavior. So if we jump over to the player and we define a private void, so it's a bit unnecessary, but for me I just always like having the access modifier a bit more clear. Private void onDrawGizmos, and we're going to say, alright, as part of this we know that our box area should draw, so we're going to say draw frame, and we're going to pass in our transform. Great. So now hopefully within Unity we can see this box that's rendered, and we can. Currently it's perfectly overlapping this square character. So let's change this a little bit. So 1 seems fine to me, but there are times where this is not quite as accurate as you need it to be. So we're just going to change it to 0.95, and for the Y, of course, we want it to be quite a bit slimmer than that, so we're just going to use 0.05 for now. So an issue we have here is that this area detection is actually centralized within the position of the body, and that's because we're using the transform as the position. So something we're probably going to want to amend our box area checker with is like an offset, which is again another serialized field. And we're going to say, okay, transform.position box offset. And because the transform position is actually returned always as a three-dimensional vector, we're just going to have to convert this into a vector 2. And because we're going to have to do the same thing here, because we want our drawing of the frame to always mimic the actual physics that we're going to apply, you might want to capture this within a separate method, but for the time being it's not necessary. You could capture this within a private method and call it in the same place, as any change to the logic here to determine the positioning of where we actually check this overlap box or draw it, a change in one of them will have to be mirrored in both places. Great. So if we go over to our player again, we can see that the box area has now got this additional vector that we can populate for the box offset. So we don't want to affect the x-axis, instead we're just going to change this to be minus 0.5, and that seems quite good to me. Okay, so let's just quickly check through and make sure that we've got it all spick and span. So it's looking pretty good. So if we go back to Unity and we give this a test run, let's have a look. So he falls, and we can still move left and right as expected, and if we jump, we can jump, and we can no longer jump in the air. So our box collision check is working as expected. Well, hopefully the advantages of SRP have been highlighted for you here, and how you can apply that within a game that you choose to develop. And hopefully it's encouraged you as well to choose to use it in your next game jam or your game development. And perhaps something to try out and see if you feel comfortable doing it, or if you have your own methods by which you prefer to approach it. I mean, as always, if you enjoyed the video or you learned something new, please give it a like. And if you have your own thoughts that you wish to share, please leave a comment in the section below, and I'll be sure to try and check them out and reply. Also, if you enjoy our content and wish to follow more tutorials regarding development or art, make sure to subscribe. We're also developing a game here at Astral Dawn Studios, which you can choose to keep up to date with as part of our devlogs, which are uploaded here every month or so. Again, thank you very much for watching, and I hope you have a nice day.